Welcome to this tutorial on how to make a metal water bottle. Before we begin, I want to give a fair warning that now that we are deeper into the semester and have already gone through quite a bit of tutorials, I will not be calling out every transform tool and their shortcuts, because it is expected that now you know that if you want to select something,
It's 9 on your keyboard for the brush selection tool.
if you want to move something, it's E on your keyboard for the move tool. If you want to scale something, it's T on your keyboard for the scale tool. And if you want to rotate something, it's R on your keyboard for the rotate tool. Something else is that I tend to forget to save while I'm recording tutorials, but I don't want you guys to forget. So I'm going to be having this little guy pop out and remind you to save every now and then. Alright, so back to the tutorial. On the Maxon site that discusses the volume builder, I saw two very different models that could be created using it, and I thought it would be fun to recreate them both. The first one is the water bottle and the cap of the water bottle specifically, which unfortunately, while they do have a video, they really are only putting already made objects into the volume builder, and I didn't want to be cruel and give that to you, so I am recreating it here. And then the second one is this little lady ice cream on the left side of the screen. So both of these models are created using the volume builder, but they're both quite different. The bottle is hard surface modeling, which means that it's an inorganic model. So something like a building or a machine would be considered hard surface modeling, while the ice cream falls more under organic modeling. So things like characters, humans, animals, all of those would be considered organic. We're going to start modeling the cap of the bottle. To begin, take out a cylinder object and make it smaller in the height to around 87 centimeters. Next, we are going to use a cube to shape the sides of the cylinder. Let's shape it to 85 centimeters in size X and Z and 120 centimeters in size Y. And then let's bring it down a little bit below the top of the cylinder. Bring in a taper deformer and make it a child of the cube.
So what I want to do is for the taper to make the bottom part bigger. So I am going to change the alignment. Instead of plus Y, which is the default, I want it to be negative Y. Then I will hit fit to parent, and now you will see that the strength, when you alter it, will be affecting the bottom of it.
I left it in negative 45%. Now we're going to make some drastically beveled edges by checking on fillet in the cube and turning the radius way up to around 25 centimeters. Of course, we also need to increase the segments because we need this to be a smooth bevel. Alright, that's looking good. Let's hide the taper deformer in the viewport, organize our object manager with proper names, and begin using the volume builder. Because this is hard surface modeling, we want our pieces to not be soft geometry, and if we leave our voxel size as is, when we turn it back into geometry, it will only calculate the big boxes of voxels and it'll be too smooth. So we need to reduce our voxel size. We can start with 1 centimeter to not overwhelm our machine, but later on we will need to go lower. Now, the Boolean operation that we want to happen between these two objects is the intersect, which will leave behind only the parts of the cube and the cylinder that are intersecting with each other. This is going to give us our basic shape for the cap of the bottle. As a reminder, you can still alter the shape after you put these into the volume builder because it stays live. But do remember that it is difficult for your computer to calculate all of these voxels moving at the same time. So later on, when we have a lot of objects and you need to make changes, I would recommend that you deactivate the volume builder and the volume mesher when we get to that before you make a change. I am going to leave this on the screen for a second so that you get an idea of the shape that we are going for. Now let's switch to the front view, and to see the shape in the front view we actually need to deactivate the volume builder for now, because the front view is in a specific display mode that does not show you voxels. Now we want to cut a shape by creating a spline with our pen tool.
So with the spline pen tool, create this triangle and then make sure you're in point mode, and with your brush selection, select the two top points and scale them down, the two right points and scale them towards the left. And what this is doing is that it is aligning those points with each other. Again, remember, when you have 2 points that are in different locations, when you scale down, the scaling is happening towards the average. So that is why they are aligned into each other.
And now let's round out this bit with the spline arc tool. Let's size and place this. And everyone's going to have different sizes and shapes, so don't worry if it doesn't look exactly like this one. We are going to use this spline to cut out the sides of this shape.
So let's make the spline a child of an extrude generator, and then increase the offset as well as moving this extrude forwards in Z so that the entire object is covered.
We want both sides to be cut out in the exact same way, so let's use a symmetry object for this. Make the extrude a child of the symmetry, and there we go, we have a perfectly symmetrical shape on the other side.
Make sure that you check off show planes so that you don't have to see that X plane in the center of the symmetry. Name your symmetry object.
Let's bring this into the volume builder, activate the volume builder, and now the Boolean operation that we want for this is subtract. You can edit the spline after the fact to alter how the cut looks by going to your selection and selecting the specific points. Remember that to select specific points, you should be in point mode, not in model mode. Now let's make this hole in the middle with a cylinder object. Change the radius to 26 centimeters and the orientation to plus X or minus X. And in all of the pictures that I saw, it was never a perfect circle, so let's bring out a bulge deformer, make it a child of the cylinder, and bulge it in the positive to 17% or something around that. To have a smooth bulge, let's increase the rotation segments of the cylinder. Bring it into the volume builder, and the Boolean operation subtract. Alright, so we're going to repeat this exact step, but make a smaller cylinder that we're going to later on put a keychain ring onto it. So bring out a cylinder, put it in the correct plane.
Make it smaller in the radius but big in the height so that it's easier to maneuver, and then position it on the top right of the cap. So my final numbers for the cylinder are 5 centimeters in the radius and then 124 centimeters in the height.
And bring it into the volume builder as a subtract Boolean operation. Make sure that you guys always name everything. And I know that what we're doing here is just using a lot of little bits and pieces that we don't necessarily know what their actual name is, but we need to be as descriptive as possible so that later on, if we want to come back and alter, let's say, the cuts that we made on the sides, we know to look for the side cuts. Right here, I'm just making small changes to the object's position in Y so that I can adjust the way that this shape looks.
The great thing about working with parametric objects is that you can always continuously make changes by simply going to the attributes of your object. So for example, here, I wanted the big hole, instead of 26 centimeters, I wanted it to be 25. You can make changes to your object as you see fit until you get to the shape that you're happy with.
Now, let's make the bottom part of the cap. Take out a tube object and let's shape and position it below our already built portion. After a bit of adjusting, I ended up with an inner radius of 30, an outer radius of 35, and a height of 33. Bring it into your volume builder and let's move on. Since by default things get added with a union operation, and that's exactly what we needed. Now let's take out a helix, put it in the correct plane, which is XZ. I want this helix to be the screw portion of the cap. So first, let's scale it down and then begin altering the helix. The star and the end radius should match, so let's make both of them 35 centimeters. We also want a lot more turns, so I'm going to increase my end angle to around 2000. I left mine at 1820, but there's no perfect number. You can do higher or lower depending on what you like. And let's make it smaller, so decreasing the height to 28 centimeters. Once it's all done, let's bring it into the volume builder. The volume builder generates geometries for splines that you add into it, which is pretty cool. But as you can see, it's hard to decipher, so it's time to reduce the voxel size to 0.5 centimeters. However, if your computer is giving you issues, you can leave it at 1. At this point, I'm just positioning things a little better. So like I mentioned, the volume builder generates voxels for splines, and we can alter how it's being generated with these options down here. The way that it fills these up is with a bunch of little spheres, and the radius decides how big the spheres are, while the density decides how dense. If you reduce the density too much, you can actually see the individual spheres. Let's leave this at radius 1 and density 5. Let's also edit the scale along spline down here. You can zoom out and pan similar to how you do it in the viewport using the shortcuts. So 1 or 2 on your keyboard, or Alt and middle mouse button and Alt and right click on your keyboard and mouse. Let's alter both of these tangents to go upwards because I like the size that it has right now. So I want my ends to stay that size, but for the middle part to get bigger. So what this is going to do now with the curve is that both of the ends are at the same exact size, and then it's going to get bigger towards the middle and then back down to the same size. Now let's be extra and add a detail on the inside of this cap. Take out a cube and make it small enough so that it fits inside of the cap. Now let's make it long in Y. The exact size that I have is 3 centimeters in X, 23 centimeters in Y, and 4 centimeters in Z. Using the move tool, let's move it so that it fits inside and touches the top part.
I actually want the cube to be a little bit longer, so in the size Y of the cube, I am going to increase that to 30 centimeters so that you can see more of the cube. Now, I will make this cube a child of a symmetry object because I want multiple copies of it. And I want them to be type radial because I want them to go all the way around. So what the symmetry object is doing right now is that it is creating copies of this cube in a circle. Once you have this, you want to make sure that you check off show planes so that you don't have to see the red planes, and you want to name your symmetry inside bits. Bring them into the volume builder and position them in whatever way looks good to you.
You just need to add one more detail. So let's cut off the bottom of this so that it can't be that clear where the tube and the helix end. Let's use a cube for this.
Change the size in Y to 16 centimeters and then bring it down in Y towards the bottom of the tube. Bring it into the volume builder and use the Boolean operation subtract. Now position it in a way so that you can't necessarily tell when the helix and the tube are ending. That way it looks like it's more merged together. And remember to name even this cutout cube.
Let's add a folder to the volume builder so that we can separate the bottom part from the top part. Bring all of the bottom parts in and make sure that they are in the right order. Remember that the volume builder works in a layer system, So if you put something that is meant to subtract and it's not in the right layer, it could remove more than we want. Once that's done, let's add an SDF smooth filter and bring it into the folder so that it only affects the objects in this folder. Remember, it has to be the upmost layer of the folder. We are using this smoothing to merge the helix and the tube together a little better.
With the SDF Smooth selected, we see some of the options underneath it. The one that we're going to change is the operator, because right now it is in Gaussian and that is used more for organic shapes. We're going to change that to mean curvature.
Increase the iterations, which is how many times the smoothing is happening. Okay, so if you notice, the volume builder with a small voxel size reveals all of the segments of your object. The smoothing will help us, but because this is not meant to be an organic shape, we can only smooth so much. So let's quickly go into our tube attributes and increase the rotation segments so that the rotation is smoother.
And in the same vein, let's also increase the rotation segment for the big hole so that it is smoother in the center, as well as the base itself. We want more rotation segments so that we don't have to see where each of the segments ends, and it's a little bit smoother. I'm adding a pretty intense amount. If this is too much for your computer, you do not have to add all of these. You can increase the voxel size, or you can also add more SDF smooth filters to try to smooth this division.
Now let's add one last detail, some bumps on the side of the cap. Bring in a circle spline and shape it around the cap.
Make sure that it is hugging the cap tightly, but that you can still see it, and that the plane is XZ.
Bring it into the volume builder, and in the case of this spline, we actually want to see the spheres of voxels. So we need to select it in the volume builder, increase the radius to make it bigger, but decrease the density to reveal the spheres.
My radius is 1.3 centimeters and my density is 0.1.
I don't want spheres all around, so let's only leave the ones on the side by taking out a cube and sizing it around the spheres that I would want to remove. Bring it into the volume builder and select subtract. Make sure that you also isolate the bump and the cube, because of course you don't want this to look the way that it does right now. You want the cube to only be affecting that circle spline. So make sure that they are both in a folder, both properly named as well as the folder properly named. Now let's go back to trying to smooth out the shape. Let's add a smooth and make that the upmost layer, and that means that it's going to affect everything underneath it, even the things that are isolated into folders. Let's change the smoothing operator from Gaussian to Laplacian flow, and this is going to leave the basic shape the same but smooth out the edges. Let's increase the iterations so that the smoothing happens over and over. I left it at around 5. Look at the difference as I'm checking it on and off. One thing that I forgot is that the helix should be removed from the tube, not added to it, since usually the tops of caps are dented in and the bottles itself are the ones that are dented out. Alright, now that we have our entire volume builder done, we want to make it a child of the volume measure so that we have the final geometry.
Remember, if you do not have the volume builder as a child of a volume measure, your objects are going to be voxels, and Cinema cannot render voxels, so you won't be able to see them in your render view.
Alright, so next we're going to make a keychain ring. This one's going to be short and simple, as we're mostly just going to be using a helix as our path, a rectangle as our contour path, and a sweep generator to generate geometry.
Okay, so take out a helix spline and put it in the plane XZ. Then we're going to make it small, so the start radius should be 30 centimeters and the end radius should also be 30 centimeters. Make it shorter. And now bring in your rectangle spline, and we're going to make this much smaller so that it looks like the keychain ring. Make both of them children of the sweep, and now you have a better visual to make the changes to the rectangle.
The width of the rectangle should be greater than the height so that you don't have a perfectly cubed ring.
And for me, the final numbers were 5 centimeters for the width and 2.3 centimeters for the height. Remember, you're welcome to make multiple changes to this. So for example, once I did this, I realized that my helix height was a little bit too big. So I went back into my helix and changed the height to 5 centimeters.
And in the sweep, I want you to check off banking, which gives you a curvature that follows your path. We want this to be flat, so check that off. And don't forget to add rounding to the contour rectangle.
As well as going into your sweep and adding cap bevels. Remember, that is clicking on the keychain ring, which I named, going to caps and increasing the size in the bevel. This will round all of the edges for this keychain ring.
Now we're going to position this in the small hole that we made. So to make it easier for us, let's enable axis so that we can change where the axis is and put the axis on the left side of our viewport in the side view. Turn off enable axis and now move your ring. So much easier to position it now. You can always further play around with all of the settings if you'd like. Let's clean up our Objects Manager really quickly by naming our volume measure and then grouping them into a null called cap. The next thing is we're going to make a bottle by using our pencil and a lathe. Bring in the reference image and let's begin making this outline. Remember that you can alter the transparency of your reference image by going to Mode, View Settings, and the Back tab and changing the transparency there.
I am also going to hide the cap null both in the viewport and the render. Now, with your spline pen tool, we are going to trace the outline of this bottle. You want the first point to be right at 0. Try your best to get close to it. You can always fix it later. And then, using your knowledge of the spline pen tool, trace an outline and also an inner spline for this bottle. Once you close your bottle, make sure that the points at the bottom are zeroed out in X.
Once you're done creating your spline, you want to make it a child of a lathe.
If you want to further edit the points to make your spline smoother, you can do that either manually or using the Spline Smooth tool. Just remember that the strength of 100% in this tool can be a little overkill, so I would suggest decreasing it a little bit.
The last thing that we're going to do is add the inner ring to the bottle. But instead of bringing the bottle into a volume builder, let's take out a tube object and line it up with the inside of the bottle.
Your numbers might be slightly different, so play around with sizing the tube inside of the bottle correctly for your specific spline drawing. However, my numbers ended up being 41 centimeters for the outer radius, 36 centimeters for the inner radius, and 44 centimeters for the height.
I also increased the rotation segments. Now let's bring in a helix and do something similar to what we did with the cap's bottom. Size it accordingly so that it fits inside of your tube. And the same end angle that we gave the cap's helix, if you remember, mine was 1820, I'm going to give it to this helix.
Reduce the height to 28 centimeters, and then once that's done, we want to bring out a brand new volume builder and make the helix and the tube a child of it.
Lower the voxel size to something small like 0.3 centimeters. And remember that you can alter how the spline looks with the radius and the density.
Decrease the radius to 1 or 1.1 centimeters and the density can be 1.
Make sure to add an SDF smooth filter to smooth it out. Put the builder as a child of the measure and make sure that everything looks how you want it. Make sure that you name everything you need to name and that you group things that should be grouped. For example, the inside of the bottle and the bottle should both be in a no. Remember, the shortcut to put things in a no is Alt-G.
Bring back the cap so that it is visible, and now we're going to use a backdrop, which we're going to make much bigger by scaling upwards, and put the bottle and the cap on it in a way that will show all of the work that we put in here. For me, this is the final placement because it helps show the inside bits, it shows the key ring, and then a lot of the work that we did also inside of the bottle. Now it's time to create materials. I will leave this completely up to you. Choose whatever colors you'd like, and then get a nice render out of this. Just as a reminder, the volume builder only allows you to put one color on the entire builder. So just know that we won't be able to put multiple colors onto the different parts of the cap.
And that's it. See you in the next tutorial.